In this lecture, we will simply learn the how to play with a dataset, how to look like a data matrix, and how to handle such kind of data, how we will use this. So, we will learn the notations of the data matrix and how to represent a data matrix. So, let's see. So, in previous lecture, we see that we have a review. That is, if we consider a text classifications, then we have a review text that is simply text. Now we will see by using some techniques, that is what to make df idf back of word, we can easily convert a text to a vector. Okay, and also for age review we have corresponding class level that govern the users. It should be positive or y or negative. So for age review we have also class level that is positive or negative. So simple, we are using interest to build a classifier if that for a given text that will give us an output of the corresponding text. Okay, this is simple tasks of a classification algorithm. This thing we have seen in previous lecture. So now the in this lecture we have seen how to handle this kind of text data set. So let's see. So first I am going to draw a table. I think in table notations it will be clearly understandable. Suppose it is our table and it's simple, it's the output. Okay, and this thing, this in just right in each row is represented a corresponding data set data. Okay, so for each row just assume that we have review I. Suppose let's take we have review I here another. Let's take here we are using another review I, that is in text format. By using some techniques we convert this text to a vector. Let's take this is our xi that we converted to it. This is our xi for corresponding text. All right, so simple this is. And in general we are taken x, we are taking a vector notations as a vector format. So we arrive for text, we by some technique we are convert this review to a text to a vector that is xi, and simple these vector notations in default in general we are using in calling a column vector. Okay, this text will be simple in a column vector. Now if you just see here, this is a review text and this is a simple vector, and this is a simple row vector, and now we are just we are just speaking that we are in general default we are presents age vector is a column vector. So this thing will be the xi transpose. Then if we just taking the transpose of this xi column vector, then it is simple, we get a row vector. Simple, this thing will be a column vector. Okay, I think you will understand this thing. Now for this review also we have a class, and the class is represented here over here. This class will be yi. Okay, simple, this thing is, this class is y. This class, this is called the class, and the total this vector, and we have seen it is a higher dimension. Suppose if we have a d, suppose after converting this review we got the vector that's dimension is, suppose let's take d, let's take its dimension is d. So the number of blocks in our, that is the here, from here to here, the number of column will be created here, d, number of d here. And for each thing, so this kind of d block we are creating for each column vector. First block, second block, dot 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 dot. Suppose let's take it is our jth block, dot dot dot, it will be our dth block. First block, second block. So such kind of, this thing is called a, this thing is called the data. Features data, simple, in another language you call the features data set or something. This thing is called the data, in the data features data. Okay, and the corresponding these features data, this is the output. Okay, so if we take the number of review, if we take the number of review for our data sets is n, suppose 1 2 suppose n number of review we have collected for a data sets. So what will be the dimensions of this matrix? That is, I am talking about now this matrix. What should be the dimensions of this? Just see the pink line, this matrix, pink color. I'm just see this, what will be the dimensions? So these dimensions will be n cross d. Okay, now see this orange color. So what should be the dimensions of this vector? That is the output vector. These dimensions will be, we have n row and o1 column, n cross 1. And if we just taking the binary classifications, just simple here I am using the binary classifications. What should be the value here? This yi should be, the value will be either positive or it will be negative. So for binary classification, so I think this geometrical structure of a general data sets, it is clear. Now let's see, if we just write this data set in mathematically, how we will write this thing. Suppose we call our total data sets, we will call this total data sets is d. Okay, so this data, we have two type of vectors. These portions, that is x I transpose, this portion is called the features vector. So for a review we have features vector xi and corresponding its output yi. Okay, and the I, we have taken the number of reviews here 1 to 10. So here I will be 1 to n, such that this symbol is simple called the such that symbol. This symbol is simple called, in mathematics this symbol is called such that. Such that, what is we, our xi, here we have taken the d-dimensional features, means xi belongs to d-dimensional. Xi is a vector of simple d-dimensional vector. Okay, and yi belongs to, if we simple for plus, just simple we are using, actually we are doing the, at the end of the day, by using this these data sets we are using the mathematics. So for a text format data or positive negative symbolic data, we cannot directly implement mathematics. So we have converted this data to mathematical notations. So simple, if we just take, we converted, we have taken these positive data sets as 1 and negative as 0. So this yi will be belongs to for what? Either it will be 0 or it will be 1. Okay, so simple, negative for 0 for negative and 1 for positive. This thing, this is the simple mathematical notations of our data sets, and it is simple the geometric type of structures. These things both are the same thing, both these things are equivalent. So in simple, this is the mathematical notations, this is the geometry, nothing else. Okay, sure. What do you find? Actually, by simple, if you just take, suppose let's take, this is our training data set. This is our training data set. If we simple take, we will see where we are actually dividing our whole data sets in two parts. In typically, we are dividing our whole data sets in two parts at 60% for training data and 40% for test data. Suppose let's take here where you simple considering the random 60% data for a whole data sets, that is our training data. Okay, so if we just call these percents of training data, so this is simple train. Let's take, it is our D train data. Similarly, we have also our D test data, just to build our classifier model as perfect as our required, as good as our required. Then only there we are using the D test data. By simple here, first what we are doing the job, our job is by using simple this D train data, we are build our classifier model. Okay, by using simple this D train data. Now by using the test data from a d-test classifier, and also we have another data set d-test, that is 40% from our whole data, and it is simple 60%. By using f, we have built using f from these data sets, and now we are interested to find and calculation. We are interested to find, suppose let's take, we are using a data from the d-test data. Okay, we are taking a data, that is this data, features data from our d-test data, and we are calculating its functional value, that is by using simple classifier. This classifier is built in from our training data, and the xi we have taken from test data. We are just justifying this output of this classifier is correct, our original output of this test data or not. If it is correct, so simple, here we have one decision level. Here we have one decision level. Correct or not? If if it is correct or not. Okay. If it is correct, yes, then we can y, I suppose let's take it is our y I hat, and its original output for this level is actually is yi. Okay, is this correct or not? If yes, then we are end, means this f is perfect, this f is okay, perfect. If no, then by simple using again text data, we are retrain our model, and we will see that how we will retrain our model. So this is depend on algorithm to algorithm, how which algorithm we are taking. If we just considering the k-nearest neighbor, then the training phase is different. If we just considering the naive base, just will see the after just will see step by step. Okay, so this is the simple structure, and this is the simple else data notations. Okay, data matrix notation. I think all the thing of the data matrix is clear, how to handle this kind of thing, how the algorithms work. These things also I am also we have seen in the previous lectures, but again I repeat here. Okay, we will see in next lecture. Okay.